Previously on the advent of cyber. Alf McSkiddy was doing a regular sweep of Santa's workshop when he discovered a hardware implant. We must try to understand what this implant was trying to do. So we have our two channels and we know we now need to change it to 9600. 9600 and click save. Then let's trash the output like we did before and then click restart on both and maybe we get something. Hello world and welcome to Hacks. We are looking at day 20 of TryHackMe's advent of cyber. Firmware, been walking around the Christmas tree. I don't have much experience with reverse engineering firmware, so this is all going to be learning as we go. I'm just going to read through the room and then do the tasks as they appear. The story. We can now learn more about the mysterious device found in Santa's workshop. Al Forensic McBlue has successfully been able to find the device ID. Now that we have the hardware device ID, help McSkiddy reverse the encrypted firmware and find interesting endpoints for IoT exploitation. And the learning objectives of this room are to find out what firmware reverse engineering is, learn techniques for extracting code from the firmware, learn how to extract hidden keys from encrypted firmware, and learn how to modify and rebuild firmware. I'm just going to click start on the machine just so we can get that going, and then we'll talk about firmware reverse engineering. What is firmware reverse engineering? Every embedded system such as cameras, routers, smartwatches has pre-installed firmware which has its own set of instructions running on the hardware's processor. It enables the hardware to communicate with other software running on the device. The firmware provides low-level control for the developer to make changes at a root level. Reverse engineering is working your way back through the code to figure out how it was built and what it does. Firmware reverse engineering is extracting the original code from the firmware binary file and verifying that the code does not carry out any malicious or unintended functionality like undesired network communication calls. Firmware reversing is usually done for security reasons to ensure the safe usage of devices that may have critical vulnerabilities leading to possible exploitation or data leakage. Consider a smartwatch whose firmware is programmed to send all incoming messages, emails to a specific IP address without any indication to the user. Firmware reverse engineering steps. The firmware is first obtained from the vendor's website or extracted from the device to perform the analysis. Then, the obtained extracted firmware, usually a binary file, is first analysed to figure out its type, bare metal or OS based. It is verified that the firmware is either encrypted or packed. The encrypted firmware is more challenging to analyse as it usually needs a tricky workaround such as reversing the previous non-encrypted releases of the firmware or performing hardware attacks like side channel attacks to fetch the encryption keys. Once the encrypted firmware is decrypted, different techniques and tools are used to perform reverse engineering based on the type. Types of firmware analysis. Firmware analysis is carried out through two techniques, static and dynamic, a bit like malware analysis that we did in the previous room. Static analysis involves essential examination of binary file contents, performing its reverse engineering and reading the assembly instructions to understand the functionality. This is done through multiple commonly used command line utilities and binary analysis tools such as binwalk, firmware modkit, FMK, firmware walker. Dynamic analysis. Firmware dynamic analysis involves running the firmware code on actual hardware and observing its behavior through emulation and hardware or software-based debugging. One of the significant advantages of dynamic analysis is to analyze unintended network communications for identifying data pilferage. The following tools are commonly used for dynamic analysis. Is that QEMU and GNU Debugger, GDB. I've used GDB before. Shall we reverse the firmware? Let's do it. So then it talks us through launching the machine and it says that the sudo password for the box is Santa1010 if we need to. After identifying the device ID, McSkiddy extracted the encrypted firmware from the device. To reverse engineer it, she needs an unencrypted version of the firmware first. Luckily, she found it online. Open a terminal and run the dir command. You should see the following directories: bin unassigned, firmware and modkits. Awesome. The bin folder contains the binary, while the firmware modkit folder contains the script for extracting and modifying the firmware in this exercise. So, step 1, verifying the encryption. In this step, McSkitty will verify the binary firmware blah 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 is encrypted through file entropy analysis. First, change the directory to the bin folder by entering the command cd to bin. She will then use binwalk tool to verify encryption using the command binwalk-e-n and then the firmware version. Okay, and it is using GPG, so of course that's encrypted. Can we make this bigger a little bit? No, we can't. Okay, so we're going to cd into the bin, and I believe it was binwalk, and it was capitals, wasn't it? -e-n, and then firmware. Brilliant. Rising entropy edge. I don't know what this means. In the above output, the rising entropy edge means the file is probably encrypted and has increased randomness. I'd love to know why. Step 2. Finding unencrypted older versions. Since the latest version is encrypted, McSkitty found an older version of the same firmware. The version is located in the bin unassigned folder. Why was she looking for an older version? Because she wants to find encryption keys that she may use to decrypt the original firmware and reverse engineer it. McSkitty has decided to use the famous FMK tool for this purpose to extract the firmware, change the directory by entering the cd command and then going into bin unsigned. She extracted the firmware by issuing the following command. So we're going to do exactly what they say. We're going to go cd up and then bin unsigned. Fantastic. And there should be a script in here that allows us to extract it. I don't see the script. So unless that's in our binary somewhere. Okay, so let's just try it. Extract -firmware.sh firmware. So that sh file must be in our binary somewhere. Fair enough. Okay, so what do we have here? Sudo password for test. So it was Santa 1010, wasn't it? Password incorrect. Firmware extraction successful. Firmware parts can be found in home test bin unsigned FMK. Step 3. Finding encryption keys. The original firmware is GPG protected, which means that we need to find a public and private key and a passphrase to decrypt the originally signed firmware. We know that the unencrypted firmware is extracted successfully and stored in the FMK folder. The easiest way to find keys is by using the grep command. The -i flag in grep command ignores case sensitivity, while the -r operator recursively searches current directory and subdirectories. So you can see that they're doing a grep -ir key in the bin unassigned, so that should automatically look in the FMK folder. Bingo, we have the public and private keys, but what about the passphrase usually used with the private key to decrypt the GPG encrypted file? So yeah, we're just gonna run that as well. Grep -ir key. I mean, it could be called anything, couldn't it? Okay, that's not what I was expecting. But you can see that FMK, root, GPG, public key, private key. So next we need to find the passphrase, and they're just doing another recursive grep for passphrase. So let's just do grep -ir passphrase. And we can see select WPA based passphrase, WP passphrase, what does it say? Secret.txt, did I see that anywhere? Did I not spell it correctly? Oh, it grepped for paraphrase. Why would it grep for paraphrase? Interesting. But what about the paraphrase? So if we do grep -ir paraphrase, that's bizarre. Santa at 2022 though, okay. Paraphrase. McSkitty has finally located the public and private keys and the paraphrase as well. I've never heard it called the paraphrase before. Passphrase maybe. Decrypting the encrypted firmware. Now that we have the keys, let's import them using the following command. So we're going to use GPG import FMK. Does this have a copy and paste thing on it? It doesn't. So I might actually have to switch back to split screen here. Right. Have I lost all my progress now? Where were we? So we need to do print working directory. So we need to cd into bin unsigned and then do gpg -import fmk root fs gpg private key, enter the passphrase, and that was Santa at 20. Oh god, I spelled wrong. Santa at 2022, I think. Secret keys imported. Awesome. While importing the private key, you will be asked to enter the passphrase that you find in step 3, importing the public key. Okay, so then we need to do gpg -import fmk root fs gpg public key, and that looks like it has processed successfully. And now we can list out the secret keys. So we just do gpg list secret keys. That looks good to me. Does that match that there? McSkitty, yep, looks good. Once the keys are imported, McSkitty decrypts the firmware using the GPG command again. Change the directory by entering the cd command. So we're going to cd up to bin, and then we're going to do GPG firmware, and then it's going to be Santa at 2022 again. Has that decrypted successfully? GPG encrypted. Whoops, did I mean to do that? Warning, no command supply. Try to guess what you mean. Created McSkitty. After decryption, once you use ls command, the decrypted file results will look like the following. Yeah, we have it. Firmware encrypted GPG. Step 5. Reversing the original encrypted firmware. This is the simplest step, and we can use bin warp or FMK to extract the code from the recently unencrypted firmware. In this example, we'll be using FMK to extract the firmware. So we're just going to do extract firmware.sh, firmware blah 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 encrypted, and you can see it's doing a bunch of stuff there. Sudo password, so that was Santa 1010. And hopefully we have found the firmware parts, so those are now in FMK in this directory, right? So what are we looking for? McSkitty has finally been able to reverse the complete firmware and extracted essential files she will use for IoT exploitation in the next room. She has used the keys from an older version 1.0 to decrypt the latest version 2.2 of the firmware. The camera folder in the rootfs directory will contain the necessary files we will begin using in the next task. And then we have the questions. What is the flag after reversing the firmware version 2.2 encrypted GPG file? The flag contains underscores. If you're seeing spaces, the underscores might not be rendering. What is it, in FMK? Or is there a flag in this text here? MD5 checksum encrypted. I don't see any flag there, so perhaps it's in the FMK folder, rootfs. And there's the flag, so we're just going to do cat fmk rootfs flag.txt, and thm we underscore got underscore the underscore firmware underscore code. What was the passphrase value for the binary firmware unsigned? So that was Santa at 2022. After reversing the encrypted firmware, you can find the build number for rootfs. Build number grep-ir build 2.6.31. Oh sweet, that was correct. And we have a wonderful Discord community, blah 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 blah. But that's it, we completed the room. I wonder how realistic this is, in that you could like go to a previous unencrypted firmware version to find the encryption keys for the encrypted version. It doesn't sound like a likely scenario to me, but maybe this is something that happens all the time. I'd actually love to know if you are an expert in this area. Comment below and let me know. But that's all I've got for you today. I enjoyed this fairly simple room. I hope it helped you get through it, and yeah, let me know if it did. Like and subscribe, and I'll see you next time. Kind regards.